See, this compiles. It does compile. So let's start adding pets and make sure everything works properly. So right here, let mutable dog equal pet. We have a new function, call you doggy, do a toString, dog that add to DB, pass in connection. We can print out the dog. Doggy dog. We can do something similar and get all of the dogs. So let pets, not all pets are dogs, pets, equal pet, get off from DB, pass that reference in, and then for pet and pets, print line, found pet. Well, keep the syntax the same. Pet. And let's see if that works. And it does. We see that doggy was printed out. The last ID, or the ID was updated, so it's the second one in the database. We see all the dogs printed out. First one was Yana, which is already in the SQL file, the all SQL. And this one came in as the second pet in the pets table. Cool. Alright, so one last thing I would like to go over is the pet owners table. So the pet owners table has foreign keys in it. And as such, I think it should be treated a little bit differently in terms of the way we look at it. So I'd like to implement some of these methods for it. I don't think we're going to implement new, just because by itself, it's just people and pets. It has no data that's native to itself, really. But I think we can still do the from database, the add to database, just not as a mutable self, just as something that doesn't deal with self at all, and the get all from database. So let's work on that. Write it right here. Why not? Derive debug, so we can print it out. Not default, debug. Struct pet owner, singular. And it's going to take an ID. Since we're never creating a new one, the ID should always exist, so we can just say that's an I32. And we can give it a person ID. I would argue person ID should be an option because the ID on person is an option. Just makes it easier to pass along. So make this an option. I32. Same thing with the pet ID. Option I32. And for person, I think that should be mandatory. Put some commas here. Make you a person. And for pet, make you a pet. Yeah. So some of the methods that we just talked about are new from DB. Let's do new from DB. Function new from DB. So if it's new from the database, I presume that I could already have all of the items needed. As in, I should already have a person, I should already have a pet. I just need to get the ID and then pass those things in. So I can do ID equals I32, person equals capital person, and then pet equals capital pet, and then what we're going to return is a pet owner. Pet owner. Right? And we do pet owner, ID, shorthand syntax, person ID, person.id, pet ID, pet.id, person, pet. And that should work. Add to database. So for an add to database, I would assume that the person and pet already exist, and they should have IDs, but we can see what happens. Function add to DB, and we want person, and we want a pet. And in this case, I think returning a pet owner makes sense because we didn't have one to begin with. So to add to DB, kind of just need this sort of syntax. Let's copy that over. Oh, we need a connection. That's what I forgot. Connection. We need a connection. Then we need to insert. And the table name is pet. I think it's owners, but we can verify that. Pet owners, yeah. And I believe it's person ID and pet ID. So technically speaking, we don't even need the person pet. But if you want to return a new pet owner, then we need them for the struct. So we can keep it. Those two parameters. Put the parameters in a new line. And it's going to be person.id.unwrap and pet.lowercase pet .id.unwrap. Right? I think so. So if that works, we can get the last inserted ID, have that as some ID, and then we can return pet owner. And we can make this a result. It looks like connection can error out, as we noted previously. So you can go back into an OK. And then pet owner is, I think we can, missing fields. Don't do it all. Well, the IDs are not necessarily none, but thank you for filling that in for me. Person.id, pet.id. Oh, this is not a self. Self doesn't exist in this scenario. And the ID is not an option, so we don't need that line at all. That looks good to me. And then I think we had one more, get all from DB. Yeah. So let's copy this here. See how we can modify this. So we need a connection. The result's gonna return a bunch of pet owners, right? And then we have this SQL statement. So in order to do this properly, you could just query that one table, the pet owners table, and get the IDs for the pet and the person, and then do 2 other queries to try to get the names of the pet and person, and then fill that in to your structs. But using 3 queries when you can use 1 doesn't really make sense. So in this scenario, I would open a SQL thingy and then try to figure out the query I need. So this is SQLite browser, and in order to test things, I can open it, I can execute SQL. I went over this in another video, but we're going to use it really quickly just to figure out what the query should be. So something that's cool is we can take all of this and then we can create a new database, make it in memory. Don't create tables via their interface. Instead, come here. Oh, is that execute single line? I want to execute all. Execute all of these lines. We see that our tables are created and we have the data that's our example data, right? And now let's try to figure out what query we need. So ultimately, we would want the ID of the pet owners table. We want the person ID, the person name, pet ID, and pet name. So those 5 items. So let's start trying to build how we build that. Yeah. Build that query. Select, start from the basics. ID from pet owners. And I can move this over a little bit. I think my face might be covering some of it. I moved it here. Select ID from pet owners. And see what that gives us. This is execute current line. And I guess it was successful. So let's be more explicit because we're going to need to join tables soon. Pet owners.id as pet owner ID. See the results here. Execute it. Pet owner ID. So we got a header. Cool. And let's do some joins. I think we can just write join, and by default it does an inner join, or we can just be explicit if we wanted to. Inner join, why not? Let's go with people first, and we want to join on whenever the pet owner dot person ID is equal to the people.id. Yeah. And then what do we want to print out? People.id as person ID. There needs to be commas here. And people.name as person name. And does that work? It does. We have pet ID, person ID, and person name. So let's do that one more time for the pets. Inner join pets on pet owners dot pet ID is equal to pets.id. And what do we want here? No. Here it is. pets.id as pet ID, and pets.name as pet name. Run that, and this looks like it's exactly what we want. We have the 1, 2, 3, 4, 5 items: the pet name, person name, pet ID, person ID, and the pet owner ID. Looks good to me. Copy that, come back here, put you on a new line because you're going to be long. And now we have to deal with the items. Okay. So the first one in the row should be the pet owner's ID. Let's probably be a little bit more explicit about that. Pet owner ID. The second item in the row is going to be the person ID. So let's do that here. Person ID, make you 1. The third item is person name. Person name. And then we do the same thing for pet. Pet ID, pet name, 0, 1, 2, it's going to be 3, and 4. And then we want to return pet owners, right? So we can first get the person. Person equal person new from DB, because we have the ID and name. Person ID, person name. Do the same thing for pet. Pet, new from DB, pet ID, pet name. And then down here, pet owner, new from DB, pet owner ID, person, and pet, right? And then down here, oh, I didn't change it, what it was up here. Just call you pet owners. Pet owners header. And you are pet owners. Pet owners iter. Make you a singular pet owner. Pet owners vect. Pet owner singular. And in return, pet owners. So hopefully we did that correctly. Let's see if this compiles. Cargo run, compiles, cool. So let's see if we can just import or just implant this into our main. So at this point in time, we have a person and we have a dog. Let's add them to the database. So let pet owner 1 maybe equal pet owner, add to database. We need a connection, so reference connection. We need a person, me. We need a pet, dog, and that is a result. Do the question mark thingy. We can print out the pet owner. Why not? Pet owner 1. What else are we gonna do? Oh, we need to get all of them from the database and then print those out. So let pet owners equal pet owners, get all from DB, pass in a connection. It's going to be result. And then for pet owner, that's a lot of noise going on outside. And pet owners, print line, found pet owner. Pet owner singular. Cross fingers, and there was an error. Dog. That was one. Yes. Pet owner consumes dog, so we can't print out dog afterwards. So pet owner will consume both dog and me, which makes sense since we now have them part of owner. And yeah, so that worked. Here's the pet owner. We have the ID for the pet owner, which is 2. We have the person ID, which is 3. The pet ID, which is 2. The person, the complete reference to person, which is Steven, and the complete reference to the pet, which is Doggy, which is what we want. And them being consumed makes sense because we wouldn't want to try to manipulate data in 2 different places. Then we have the found people, the found dogs, and the pet owners, which there are 2, 1 and 2. The one that was initially in the database and the one we just added. So overall, that's how I thought of how to deal with your tables that are just mainly references. Oh, and lastly, one thing I think we should change is this database. So we're using the SQL for all this stuff because it has examples in it, and we were able to utilize those examples to figure out how to make everything work. But now that we have everything working, we can just go to the schemas file and use that one. So if you remember what the difference is, all has some dummy data, but schemas does not. And then make sure that still works, and it does. And now the only output that we're getting is the data that we put in the main function. So pet owners, there's only one. There's only Steven. There's only one pet, Doggy, and there's only one pet owner. And with that being said, that is the end of the video. I hope you liked this tutorial, or at least introduction to SQLite and interacting with it in Rust. Ooh, there was one thing I did forget. So the documentation for this crate is something that you should look at because the optional features are interesting. So there are 2 I'm going to note. You should probably read through the rest of them just in case you see if you want them. But the 2 that captured my attention are the chrono option, which seemingly allows you to, well, chrono is a date time crate, so you can use it for formatting dates and doing things of the like. But if you use that here, then you can do the conversions. They'll do the conversions for you. So using date times in your database is probably easier via that option. And then also the bundled option, which uses a bundled version of SQLite 3. This is a good option for cases where linking to SQLite 3 is complicated, such as Windows. So yeah, the bundled option just seems amazing in terms of convenience. And also one thing that should be noted, while trying to figure out how I was going to do this tutorial, I downloaded the bundle, and the bundle version of SQLite is newer than my system's version of SQLite. So that's something that's to be noted as well. So with that, we have reached the end of this video, this tutorial. If you like to hit like, subscribe, yada yada yada. Aside of that, peace.